This podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Services. In this presentation, we're going to learn to solve compound inequalities and graph them. Your guided questions: what does a compound inequality look like? Demonstrate the steps and graph the compound inequality. So when we're talking about compound inequalities, essentially what we're doing is we're taking two different equalities and making them into one. So here's one compound inequality: 2x plus 3 is greater than or equal to negative 5. And the second compound inequality, 2x plus 3 is less than 9. And essentially we're taking those same things. You notice that the 2x plus 3 are the same on both sides, and we're putting the equation side in the center, and we're putting our inequalities aligned in the same direction, and putting our outside of our inequality signs there. So the inequality is read: 2x plus 3 is less than 9 and greater than or equal to negative 5. You could reverse that as well. You could say 2x plus 3 is greater than or equal to negative 5 and less than 9. So what we're going to do is we're going to go ahead and solve this. We're going to subtract 3 on both sides of the inequality sign. Now you notice that I'm doing everything in the center and then on both sides. Then we're going to simplify. My negative 3's will cancel, and I'm left with a 6 here. I'm left with a negative 8 here, and I bring everything else down. Now we're going to solve for this by dividing 2 to everything. And what we're left with is x is less than or equal to 6 over 2 is 3, and negative 8 divided by 2 is a negative 4. So now our equation reads x is less than 3 and x is greater than or equal to negative 4. So if we're going to write that on a number line, my two numbers are negative 4 and a positive 3. The number above positive 3 is open. This number is closed. X is less than 3, so it's going to run in this direction. And x is greater than or equal to negative 4, it's going to run in this direction. So they run towards each other. Essentially, it can be negative 4, anything to the left, up to 2.99999, but it couldn't be 3. Okay, so let's try that again. We are going to, so my inequality is negative 4x minus 7 is less than 5 and greater than negative 15. And what I'm going to do is I'm going to add 7 to everything. And then I'm going to simplify. This cancels. I'm left with a negative 4x in the center. This is going to become a negative 8. And this is going to become a 12. Now I'm dividing by negative 4. Now the same rules apply, that whenever I'm doing the reciprocal of a negative number, remember this is negative 4, this is negative 4 over 1, so it's 1 over 4, which is essentially dividing by negative 4. Whenever I divide by a negative 4 or multiply by a negative number and I'm dealing with inequalities, my inequality signs have to switch directions. So this one is going to change these right now, greater than or equal to, and this one is going to be greater than or equal to. 12 divided by a negative 4 is a negative 3, and negative 8 divided by negative 4 is a positive 2. And we're left with x on the inside. Again, if I'm going to graph these on my number line, my numbers that I'm dealing with are 2. I'm going to write my 2 on the right side because it's a positive, and the negative 3 on the left side. Both of them are solid lines, solid dots, excuse me. X is greater than negative 3, well, it runs in this direction. X is greater than 2, so it runs in this direction.